LeetCode Problem 145, Binary Tree Postorder Traversal. Given the root of a binary tree, return the postorder traversal of its node's values. Example 1. We're given the following input that looks like this, and this is the expected output. Example 2. We're given the following input that looks like this, and this is the expected output. This example 2 is what we're going to cover in our whiteboard walkthrough. The approach that we're taking is called the two-stack postorder traversal. It uses two stacks as part of the solution, has a time complexity of O of n and a space complexity of O of n. Now let's walk through the example. We're given nodes 1, 2, 3, 4 and 5 structured like so. First thing we want to do is declare three variables: stack, which is an empty stack, stack 2, which is an empty stack, and the result, which is an empty array. We'll handle an edge case where we check if root equals null, returning result if it does. Step 2. Push root onto the stack. Step 3. While stack is not empty, pop the node off the stack as current node, load the current node value into stack 2, push the left child node, then the right child node onto the stack if they're not null. Step 4. While stack 2 is not empty, pop stack 2 and load the value to the result. So the root is 1, so let's push that to the stack. Then we can see the stack is not empty, so pop the stack, so the current node is now the 1 node. Add 1 to stack 2. We can see that it has a left node, so add the 2 node to the stack. The same with the right node, add the 3 node to the stack. We can see the stack is not empty, so pop the stack, so the current node is now the 3 node. Add the value 3 to the stack 2. Check if it has a left node, which it does not. Check if it has a right node, which it does not. So we'll go back to the top and check if the stack is empty. The stack is not empty, so pop the stack, so the current node is now equal to the 2 node. Add 2 to stack 2. Check if it has a left node, which it does, so push the left node to the stack, which is the 4. Do the same with the right hand side, so push the 5 node to the stack. Back to the top, and while the stack is not empty, which it's not, pop the stack, so the current node is now the 5 node. Push the value 5 to stack 2. Check if it has a left node, which it does not. Check if it has a right node, which again it does not. So back up, check if the stack is not empty, which it's not. Pop the stack, so the current node is now equal to the 4 node. Then add the 4 value to stack 2. Check if it has a left node, it does not. Check if it has a right node, it does not. We can see that the stack is now empty, so we'll break out of this while loop. While stack 2 is not empty, we can see it's not. Then pop stack 2 and add the value to the result. And then we repeat this to reverse stack 2 into the result. So next we'll then add the 2 into the result. Then we want to add the 3 into the result. And then finally we're going to add the 1 into the result. Break out of the while loop because stack 2 is empty, and step 5, return the result. Result equals 4, 5, 2, 3 and 1, which is exactly what we expected. Well, thank you very much for watching. It's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. LeetCode Problem 145, Binary Tree Postorder Traversal, in JavaScript. Given the root of a binary tree, return the postorder traversal of its node values. Example 1. We're given the following input. The output is going to be 3, 2, and 1. The second example, we're given the following input that looks like this. The output is going to be 4, 6, 7, 5, 2, 9, 8, 3, and 1. Example 3. We're given an empty tree where root is going to equal null. The output is going to be an empty array, as we can see here. And then finally, example 4, we're given a single node tree. The output is going to be an array with just the single value, which was the input node. So in terms of edge cases, I think there's 3 edge cases that are sort of demonstrated here. So the first edge case which I'll cover is in example 3, which is when we are given root equal to null. So we're given an empty tree. So in that scenario, what we want to do is we want to return an empty array. We don't want to return root, because if we do return root, then we're going to be returning null. And as you can see, the return type of this is it's an array of numbers, or an integer array. So this is an edge case that we're going to need to handle, and I'll show you how to do that shortly. The second example in terms of an edge case is example 4, which is where we're given a single node in the tree. Again, the output, we just want to output that value as an integer in the array. Real nice and easy one to handle. So again, we'll make sure that our solution covers that. And then a final example, which I think is covered in example 1 of an edge case, is where we've got a tree where the nodes might not have a left child but do have a right child, similar to what we can see here. So the 1, it's got no left child, so the left node is null, but it does have a right hand child. And then the 2 node as well, we can see that it does have a left node, but it does not have a right node. So this is just another edge case which our solution's going to need to handle. Cool, now let's get into it. So I don't know if you've seen any of my other videos, but I do a video on pre-order traversal. So to solve this problem, you basically do pre-order traversal, but instead of loading to the stack the right node, you want to load the left node first. And that is because we use 2 stacks, and we pop off the stack, then reversing the order that we store. So what I'll do is I'll write out the solution, and I'll explain this in further detail once we've fully implemented the solution. Cool, so the first thing that we're going to do is we're going to declare 2 stacks. So we'll have one called stack and set it equal to an empty stack. And then we'll have another one called stack2, and we'll also have that as an empty stack. And then finally we want to have a result, which is going to be an empty array where we're going to store integer values. Cool. So what we want to do now is we want to handle the edge case, which is where root is equal to null. So we'll say if root, well, if not root, because JavaScript will say that this will be true if root is null, basically. Then what we're going to do is we just want to return result, which is the empty array. So we've handled example 3's edge case. Cool. Then what we want to do is while, no it's not, what we want to do next is we want to push root to the stack. So stack.push root, and then we want to say while stack dot length is greater than 0. Then what we want to do is we want to traverse through the tree. So what have we got? We got stack, so then we want to say current node, is equal to stack.pop. So we've popped the 1 off the stack, and then what we want to do is we want to load that result, that value. So we want to do, we want to load that value to stack 2. So stack 2.push current node.val. So that's now loaded into stack 2. We want to check if current node.left. If we have a left node, we want to push that to the stack. So stack dot push current node.left, and we do the same for the right as well. So if current node.right, then stack.push current node.right. Okay, cool. And then what we want to do, so basically this is very similar to pre-order traversal, but we've switched this part here. And the reason that we've switched this part here is because we're adding it to this stack 2, and this stack 2 we're now going to reverse it. So let's reverse that. So we'll say while stack 2.length is greater than 0. Then what we want to do is we want to do result.push stack 2.pop, and finally we then return result. Let's run that, see if it works. It does, excellent. And then we'll submit that and we will see if it passes the edge cases. So submit. Brilliant, it's passed the edge cases. So we can see that it beats 100% in terms of runtime, but it only beats 7.38% in terms of memory. I can tell you that the runtime complexity of this solution is O of n, and the space complexity is also O of n. There is an improved way of doing this, reducing the memory. It's more complex, and I will be making a video for that in the future. Once I've made that video, it'll be in the description below. But this is widely accepted in an interview scenario as being an acceptable solution to this problem. If you could please click like if you like the video, it's going to hugely help me out. Hit the notification bell if you'd like to see future videos. And if there's anything that you can think I can improve on, or you've got any questions or any videos that you'd like me to produce in the future, please leave them in the comments below and I will get back to you. Thank you very much for watching and good luck with your coding.